So you got two mice in separate mazes. There's only one path that leads to the cheese. The first maze has 4 paths. 3 of them are dead ends. Second maze has 5 paths. 4 of them are dead ends. The mice go at the same speed. All 9 of the paths are the same length. Each mouse decides at random which path to take first, equal chance of taking each path. If it goes to a dead end, the mouse goes back to the starting point at the same speed, picks one of the remaining paths at random, then same chance of taking each of the untrodden paths. Keeps going until each mouse finds the cheese. The mice are independent of each other. And the question is, what's the chance that the mouse in the first maze takes less time to find the cheese than the mouse in the second maze? Okay. Does this sound at all like a problem we already solved today? No. Because that problem was about coins. That's completely different from random mice. Yeah. This is a lot like the chance that the number of heads in the first 3 tosses is less than or equal to the number of chances in the number of heads in the last 2 tosses. Yes? Okay. What's the chance that, so what are the possibilities? How does the first mouse win? Well, first mouse can take 1, 2, 3, or all 4 paths before finding the cheese, right? So there's 4 possibilities. First mouse can take 1, 2, 3, or 4. Second mouse can take 1, 2, 3, 4, or 5, right? What's the chance the first mouse takes less paths? Well, if the second mouse takes 1 path, the first mouse can't take less. Okay? If the second mouse takes 2 paths, then if the first mouse takes 1, he wins. If the second mouse takes 3, the first one takes 1 or 2, he wins, etc. Right? So the outcomes that correspond to the first mouse winning are 1 from here, 2 from here, 1 or 2 from here, 3 from here, 1, 2, or 3 from here, 4 from there, 1, 2, 3, and that, or 4, and 5 from there. Yes? Those are the outcomes that correspond to the first mouse taking less time. The mice are independent. The chance the first mouse takes 1 path to find the cheese is what? What's the chance that, so there's 4 paths to pick from. What's the chance it's the first path the mouse picks? Mouth pick. 1/4, okay? What's the chance that the second mouse takes exactly 2 paths? So the chance of this is 1/4. What's the chance the second mouse takes exactly 2? For that to happen, the first guess of this mouse has to be wrong, and then the second guess has to be right. Yes? What's the chance that the first guess is wrong? Okay, 4/5. And then if the first guess is wrong, what's the chance the second guess is right? 1/4, right? There's still 1 right path left. There's 4 paths remaining. The mouse is picking equally likely, each one with equal probability. So the chance that this takes exactly 2 paths is 4/5 times 1/4. Okay? What about this? Chance that it takes 1 or 2? Well, chance it takes exactly 1 is 1/4. Chance it takes exactly 2 is 3/4 times 1/3, right? Okay, so 1/4 plus 3/4 times 1/3 is this one taking 1 or 2. What's the chance this mouse takes exactly 3? Well, he's got to be wrong the first time, be wrong the second time, and be right the third time. Yep. Okay. All right, so this is basically the story. And then to find the chance that this happens and this happens, we take this chance times this chance. We've partitioned everything. We add the results to get the overall probability. Okay. Yes?
So we're going to take the probability of all this column times probability.
No, in each row, we're going to multiply this times this.
I have a new column?
To get a new column, because that's the chance that this happens and this happens. Okay, but this corresponds to one way that the first mouse can win. Okay. This is a disjoint way that the first mouse can win. This is a disjoint way that the first mouse can win. So we're going to add those probabilities.